Hello everyone, today I'll talk about the solution to the problem sum of prefix scores of strings. While the statement is not very long, the thing that we want to calculate is very contrived, and so it is clear from the get-go that the solution will probably be using trees. That is, tree as in retrieval, and if you're unfamiliar, you might want to look at some previous dailies. This is one of the series of daily challenges on LeetCode that utilizes trees in model solutions, or you might stick around here and since it's not a very difficult data structure, you might just come up with the main ideas yourself. Now, I said that it's immediately obvious that this solution will use trees, but if it's not obvious to you, it doesn't really matter because since a tree is just one way of visualizing a list of words, a set of words, a dictionary in the standard sense, you might just try to use it as the main way you visualize some of the string problems. And since here it might be quite difficult to understand what we're actually being asked to calculate, let's walk through it, what the question here is, but while visualizing our words as a tree, and then the solution will jump out at us. So we are given here an example in the statement. So we have our tree starting from the empty prefix, then we have A. This node is marked since we have the word consisting of only A. Then we have B. AB is also a word. Here we have C. ABC is also a word. Here we also have C, A, B, and this is also a word. So with dots I mark what nodes are marked as being ends of words. Now for a single word we're being told that the score is the number of strings in our dictionary that are prefixes of that word, or that word is a prefix of them rather. So for instance, if our word is AB, then AB is a prefix of AB in our dictionary and ABC in our dictionary, so the answer is 2 for the word AB, and this is what we were being told here. So for the word C, the score would be 1 because C is a prefix of CAB and nothing else. And now we want to calculate not the score of every string in our list of words, but for every word in our list of words, the sum of scores of every non-empty prefix of that word. So that means that every marked node here is a word in our dictionary. So the score for this word, this augmented score that we want to calculate, is the sum of scores for all the prefixes of that word. So the score for AB, which is a prefix consisting of the whole string, is 2. And the score for A is 3, because A is a prefix of A, AB, and ABC. So the big score for AB, let's say, is equal to 5. For CAB, this is a sum of scores for CAB, CA, and C. All of those are prefixes of exactly CAB, so the score is 3. So how can we look and augment our data structure to make answering those questions easy? Well, we can clearly see what we want to do for every prefix. So for instance, how do we calculate the simple score for AB, the thing that's given here as an example? Well, we have to count the number of dots in the subtree rooted in our node. So that's one way of looking at it. But then we want to get the sum over all the prefixes. And it's not difficult to see that if we want the sum over all the prefixes of how many words it's a prefix of, then for every word that we have, let's say the word ABC, then it should add 1 to the scores of A, AB, and ABC. So add exactly 1 to all of those and nothing to anything else. So it should add 1 on the path from root to the node corresponding to ABC. And so if we insert, while inserting every word, we increment the path it goes through by 1, then at the end in every node we have the simple score of the word corresponding to that node. Right? So after that incrementation, here we have a 1, here we have a 2, here we have a 3, here we have a 1, here we have a 1, here we have a 1. And now, what is the answer for our question? Well, the answer is, when we're looking, for instance, at the word AB, is the sum of scores on the path from the root to that node. So 3 plus 2 equals 5, here 1 plus 1 plus 1 equals 3. So while inserting, we increment the whole path by 1, while querying, we calculate the whole path from root to the node and sum up all the scores. And this is the whole solution. So first, our baseline tree implementation is almost unchanged. The only thing that we have to keep in mind is now that the node has a score, and while inserting, we increment the score of every current node. We skip the root node because we're only interested in non-empty prefixes, so the root node should have the score of 0, or we should just skip it. Now to calculate a score, we do almost exactly the same thing as when inserting, only now we keep in mind the score, and whenever we descend into a child, we add its score to the result, and that is the result for that word. So in that sense, after this insert, when we insert all the words, we get the simple score for every node being written in that node. And now to calculate the big score, the score that we have to return, we have to sum up over all those scores. And this is exactly what we do. We initialize the tree, we insert every word from our dictionary, and what we return is for every word in our dictionary, we get the tree and calculate the score for that word, which will descend the tree to the node corresponding to that word, while adding the scores into a total that is the total score.